Okay, we are going to look at this word problem. It's a little bit of a contrived word problem. This is one from our textbook that we use in the section on absolute extrema of functions. So it's a little bit contrived, but the things I want to focus on are what are the key things in this problem that are telling us what we need to do to connect to the math that we've been learning. Okay, so we are given this function. It tells us what that function describes. It gives us an interval of x values for which that function is a good descriptor. And then this is where they ask us to do the math. Find where the pollution, that's the output of the function, is the least. So that's a minimum value. All right, so we also have an interval here. This is an interval 0 to 50. On a lot of the problems we did where we were just looking at functions that were given without a kind of word problem surrounding them, they stated our intervals like this. The word problems, for whatever reason, they often state them like this. Okay, so in essence, this is an absolute extrema problem on a closed and bounded interval A to B, where the endpoints are included. All right, so we are finding in this case not an absolute maximum and minimum. We really just want the absolute minimum. It doesn't say absolute or local, but if we want the least, that is going to be the absolute minimum. Okay, so just thinking back to how we do that when we have an ordinary function that's not in the middle of a word problem here, we look for the critical points of the function, or critical values or critical numbers. All of those are different ways of asking for that. So that's where the derivative is equal to 0 or does not exist. So let's start by finding the derivative. Pretty straightforward derivative here, nicely enough. I want to think about where that derivative does not exist. So I'm thinking about this 6x minus 72. That exists everywhere, so not on this problem. And then I want to think about where the derivative is equal to 0. I'm going to set 0 equal to that derivative. Unlike some of the problems we've done, this is pretty easy algebra. Just add 72 to both sides and then divide through by 6, and we'll get x equals 12. Okay, so when we do absolute extrema problems, we're really just interested in the output of the function. And so we will make an xy chart here. And we want critical points that are in the interval we're interested in. So our only critical point is 12, and it is in this interval. So we'll put x equals 12 there. And then we're going to put in our values here, 0 and 50, for the ends of the interval. All right, so I'm going to put in these numbers to my function. I'm going to grab my calculator. Actually, I'm going to grab my scratch paper where I already did this. Okay, so I'm going to put these numbers into my function. Putting in x equals 0 is actually easy enough. I could do that without my calculator or my scratch paper, because when I put in x equals 0, I'll just get 576. But these other values, when I put in 12 for x, we're going to want to multiply that all out. When I put in x equals 12, I get 144. And when I put in x equals 50 into my function here, I will get 4,476. Okay, so what we are interested in here, though, is where this pollution, the output of the function, is the least, the absolute minimum. So I'm just looking for the lowest of these values. So this is the minimum value, or the least, and it occurs at x equals 12. All right, in this case, since we have a word problem, we maybe want to label the units on those answers. So the pollution is at a minimum of 144, paying attention to units, parts per million. I'll abbreviate that here. Parts per million at x equals 12. 12 represents the number of miles from factory A toward factory B. So 12 miles from factory A. Okay, so there is the answer to our problem. Sometimes we talk about graphs and how those could maybe help you. In this one in particular, I want to just point out that maybe you could have done this one without knowing calculus. If you recognize that this function that I'm working with here is a parabola with a lead coefficient that is positive, you would know that that's a parabola that opens up. And so the only low point on that parabola would be at the vertex of the parabola. This happens to be the coordinates of the vertex of that parabola. So occasionally there are some algebra things that you might know that could help you not have to use the calculus in the problem. That's okay as well. If this were something besides a parabola, pretty simple graph that you know a lot about from algebra, then you would go through this process as well. All right, try some homework, and we'll do some more problems in some more videos.